The pump truck had come off the access road at 20 past 8 in the morning. Not from speed. The access road into the Steinbach Gorge was barely 4 meters wide, carved into the left wall of the gorge in 1951, when the dam construction project had first been surveyed, blasted through limestone with the minimum clearance required to move construction equipment in single file. At its narrowest point, where the gorge pinched inward at the second bend, the road left perhaps 30 centimeters on either side of a standard-width vehicle. This was enough for controlled movement in daylight under normal conditions. The conditions at 20 past 8 on a February morning had not been normal. The overnight frost had found the drainage seep at the inside edge of the second bend and turned it into a surface that was, in technical terms, a bearing failure. A thin film of ice over limestone dust over saturated clay, approximately 1 meter wide and 3 meters long, that occupied precisely the section of road where the pump truck's right rear wheels needed to maintain contact. They had not maintained contact. The wheels had gone first, then the rear of the vehicle, then everything with any logic had followed, and the pump truck, a 9-ton concrete pumping unit with its boom in the transport position, had come to rest with its right side against the gorge wall, its left side overhanging the gorge floor 3 meters below, and its entire mass balanced between these 2 points in a way that would not remain stable for long. The driver had not been hurt. He had stayed in the cab for 4 minutes while the machine found its equilibrium, and then had climbed out through the driver's window, which was now the highest point of the cab, and walked carefully to the inner gorge wall and back to the site compound. Dieter Krantz, the dam construction chief engineer, had been on the access road within 15 minutes. By the time he had assessed the situation, he was already calculating in terms of days rather than hours. If this is your first story on this channel, subscribe now and hit the bell. New story every single day. Let me tell you about the Steinbach Gorge and why it produced problems that modern engineering equipment was not designed to solve. The Steinbach was a tributary of the Isar, dropping from the Bavarian Prealps through a limestone gorge that had been cutting its channel since before the last ice age. The gorge was not deep by alpine standards, perhaps 20 meters from rim to floor, but it was narrow, and it was narrow in the specific way of water-cut limestone canyons, which is irregular and unpredictable rather than uniform. In places the gorge was 12 meters wide and would have presented no particular engineering challenge. At the second bend, the limestone buttresses on either side converged to a width of 7 meters, of which the access road occupied 4. The construction company had been building the Steinbach hydroelectric dam since 1954 under contract to the Bavarian State Power Authority. The project required a series of concrete pour operations in the gorge floor, for which the pump truck was the primary piece of equipment. Without the pump truck in position, no concrete could be placed. Without concrete being placed, the dam schedule, which was already 11 days behind, would fall further behind. The project engineer in Munich used the word significant in relation to the contractual penalties. He said it carefully. The available recovery equipment was a tracked excavator and a mobile crane. The excavator was already in the gorge, on the downhill side of the pump truck. It could not approach from the rear without the risk of pushing the pump truck over the gorge edge. The mobile crane had been driven to the gorge entrance and stopped. Its boom extended to 14 meters. The gorge at the second bend was 7 meters wide. No configuration of the crane's geometry allowed it to operate within the gorge, without the risk of the boom contacting the limestone walls. Krantz had requested a longer crane from the district depot. The district depot had one available, but it was the same model and the same width. The operator had been honest about this on the phone. By 11 o'clock, Krantz had accepted that the answer was not coming from the equipment catalog. It was at 11:15. While he was standing at the gorge entrance staring at the access road, that Anton Bruckner appeared from the path that came down from the upper rim. Anton Bruckner was 67 years old. He had been farming the land on the east rim of the Steinbach Gorge since 1930, when he had taken over the farm from his uncle at the age of 18. In 27 years of farming the rim land, he had gone into the gorge regularly, for the hay meadow on the gorge floor that his family had been cutting since 1891, for maintenance of the stone weir that directed water to the farm's mill channel, for the occasional recovery of livestock that found the gorge edge. He knew the gorge the way people know places they have used for practical purposes over a long time, not dramatically but specifically, in terms of what was where and what that meant for what you were trying to do. He knew the second bend. He knew the ice seep at the inside edge that formed every February when the morning temperature dropped below -4. He had been avoiding that section of the gorge in early morning for 20 years. He had mentioned it to the construction site foreman in 1954 when the project started, and the foreman had written it in his maintenance log, and nothing had been done about it. He knew something else about the gorge that was not in any document the construction company had access to: the old mule track. The mule track had been cut into the right wall of the gorge, the wall opposite the access road, in 1889, during the construction of the original Steinbach drainage canal. The canal company had needed a way to move their mule-drawn carts through the gorge above the canal level, and they had blasted and cut a track approximately 60 centimeters wide, running from the gorge entrance to the canal intake at the upper end. When the canal had been decommissioned in 1931 and the infrastructure abandoned, the track had been left. By 1957, 26 years of vegetation growth had concealed the track entrance from the gorge road. Anton had no difficulty locating it. His uncle had shown him the track when he taught him the gorge, and his uncle had used it before him, and the canal workers had cut it before that. 3 generations of practical use, none of it written down anywhere. The track at the level of the second bend ran approximately 2 meters above the pump truck's current resting position. From the track at that specific point, a winch cable attached to the pump truck's upper chassis would create an upward lateral pull, exactly the force vector needed to rotate the pump truck back onto the access road from its current half-overhanging position. Anton had worked this out on the walk down. He arrived at the gorge entrance and found Krantz standing there. He looked at the pump truck. He said, "There is an old mule track on the right wall, 1889. It runs above the second bend. From the track, the winch angle to the top of the chassis is correct." Krantz looked at him. "A mule track," he said. "From the Steinbach Canal construction, 1889. I use it to access the gorge floor from my farm." He looked at Krantz. "The lance will fit on the track. The track will hold the lance. From the track, the pump truck comes up rather than over the edge." "The track is how wide?" Krantz said. 60 centimeters, possibly 70. It was built for a mule and a light cart. The lance's front axle is narrower than the track width. The rear axle is wider, but the track has an outer retaining wall from the original construction that will support it. One of the construction workers said something to another worker. The second worker looked at the lance and then at the gorge with an expression that contained his assessment. Krantz looked at the pump truck, at the contractual penalties, at the crane that could not fit inside the gorge, at Anton Bruckner, 67 years old, who was standing at the gorge entrance telling him about an 1889 mule track. "How long?" Krantz said. Anton said, "An hour to get the lance on the track and positioned. Then the pull. The machine will cooperate if the angle is right." "All right," Krantz said. "Let me tell you what Anton Bruckner understood about gorge recovery that made this approach possible when everything else was not. The problem with the pump truck was geometry and access. The machine was in a position that could not be reached from the access road without risking further destabilization, and could not be reached from above because the crane could not enter the gorge. The only remaining access was from the side, from the gorge wall itself, And the gorge wall on the right side happened to have, at exactly the right height, a 68-year-old mule track not visible from the road and not in any engineering survey. From the mule track at the second bend, the Lance's winch cable could reach the upper chassis of the pump truck at approximately 45 degrees upward lateral. This angle would pull the pump truck's upper side toward the right wall, the direction of safety. It would lift the machine's center of mass slightly as it pulled, reducing the tendency to tip further left. It would rotate the rear axle back toward the road's surface as the machine moved, allowing the road itself to provide the final bearing support. None of these properties were available from the access road or from the crane position at the gorge entrance. The Lance contributed two things. First, its narrowness. The track was 68 centimeters wide where Anton had measured it most recently. The Lance's front axle was 62 centimeters. The rear axle was wider 94 centimeters, but the track had a low outer retaining wall of stacked limestone from the 1889 construction that ran along its outer edge, and this wall was solid enough to support the rear axle's overhang while the front axle occupied the track's surface. Second, the flywheel. The pump truck's chassis, once the pull began, would need to rotate around its current fulcrum, the right gorge wall, back toward the road. This rotation required continuous, sustained force applied at the correct angle. Any surge or jerk would risk completing the rotation in the wrong direction. The Lance's flywheel prevented surging. 1 stroke per second, 80 kilograms of spinning iron releasing the energy of each stroke smoothly. The pull would be continuous and unhurried, and the pump truck would rotate back toward the road at the speed it could manage. Subscribe now if you have not, because what happens in the Steinbach Gorge in the next hour is why the damn construction workers still talk about Anton Bruckner. He heated the glue kopf at the gorge entrance. February in a mountain gorge is colder than February in the open. The gorge walls hold the night temperature, and the morning sun does not reach the floor until past 10. The cast-iron hot bulb chamber needed 12 minutes. Anton held the torch steady against the iron dome and waited. He had done this in worse cold, in the 1947 winter that people in the valley called simply the bad one. 12 minutes in a February gorge was nothing remarkable. 12 minutes, the color arrived. He set the torch aside. Starting crank, first turn, the flywheel moved. Second turn, his weight fully behind it. Third turn. The engine fired. Pum! The sound went into the gorge and came back from the limestone walls on either side, the gorge concentrating it, sending it back multiplied. A single pum became something that filled the gorge and faded slowly. The construction workers were quiet. Pum! 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 1 beat per second in a Bavarian mountain gorge in February. The exhaust pipe sent its smoke into the cold gorge air, rising until it found the top of the walls and dispersed into the open sky above. Anton climbed onto the open seat and drove the Lance to the gorge entrance. He found the mule track entrance on the right wall approximately 15 meters inside, a gap in the vegetation at head height, the limestone step worn smooth by decades of mule traffic. He had found it the same way every time, by counting paces from the entrance marker, which was a crack in the limestone wall shaped like a fork, which had been there since before he was born. He positioned the Lance at the base of the wall and engaged the front axle into the climbing approach. The front axle found the track. The rear axle's outer edge rested on the 1889 limestone retaining wall. The Lance tilted slightly inward toward the gorge wall and settled. Anton tested the brake. The machine held. The track held. He drove forward. Hit subscribe and the bell. New story every single day. Stay with this. Pum pum pum. The track ran along the right wall of the gorge at approximately 2 meters above the access road level. From here, Anton could see both the road below and the pump truck at the second bend. The machine's left side still over the gorge floor, its right side against the left gorge wall. He could see the toe point on the upper frame. He stopped level with the pump truck. He attached the winch cable to the upper frame toe point, reached down and across at the correct angle. He tested the attachment. He walked back to the lance. He climbed on. He engaged the winch drum. Pum pum pum. The cable came taut. The flywheel turned. The gorge was quiet except for the engine beat and the cable tension. For 20 seconds the pump truck did not move. The cable was tight. The machine sat against the limestone wall with 8 months of construction vibration having settled its weight against the gorge, and gravity waiting to complete the job in the other direction, and the lance was asking it to choose a different outcome. The flywheel turned. Then the pump truck moved. Not the direction gravity wanted. Toward the right wall, toward the mule track, toward safety. The upper chassis rotating around the fulcrum of the road edge. The rear axle moving back toward the road surface as the upper side came toward the wall. The machine behaving exactly as the geometry had predicted. 4 centimeters, 8. Krantz, standing at the second bend with 2 of his crew, was watching the chassis angle. He had been watching for 20 seconds with the specific concentration of an engineer whose problem is being solved by a mechanism he did not design and had not expected. The rear axle found the road surface. Not fully, it found the edge of the road surface. But once the rear axle was on the road edge, the road could begin to carry the weight. The pump truck was no longer purely balanced between the limestone wall and open air. It had a third support. Anton held the throttle. The flywheel held the pull. Krantz, without being asked, positioned his crew at the road edge to guide the rear axle as it settled. The pump truck rotated back onto the access road. It was on the road at 9 minutes past noon. Anton disengaged the winch. He drove the lance back along the mule track to the gorge entrance and down to the road level and parked. Pum pum pum. Krantz came to him when the pump truck had been secured. Bruckner, he said. Anton was checking the winch cable. The mule track, 1889. How long have you known about it? Since I was a boy, Anton said. My uncle showed it to me when he taught me the gorge. He had used it since the 1920s, before him, his father. He set down the cable. The canal workers built it. They left it because stone is easier to leave than to remove. It is not on any survey we have of the gorge, Krantz said. It would not be. It is from 1889. Your surveys are from 1951. Anton looked at the pump truck, now upright on the road. I told your foreman about the ice seep at the second bend in 1954. He wrote it in the log. He looked at Krantz. The log is presumably still in the site office. Krantz was quiet for a long time. I will look at the log, he said. You should, Anton said. He climbed onto the lance and drove out of the gorge. Pum pum pum. The dam was completed in 1959, 11 months behind the contracted schedule. The ice seep at the second bend was treated with drainage gratting and a heated road section in November 1957. No other vehicle went off the access road during the remainder of the construction. The 1889 mule track was surveyed by the Dam Authority in December 1957 and added to the gorge infrastructure records. The survey noted, limestone construction, original 1889 canal access, load rating confirmed adequate for light agricultural vehicles. It was used twice more during the dam construction period. After the dam was completed, the gorge access road was improved and the mule track fell back into the vegetation. Anton Bruckner continued farming the East Rim until 1971. The Lanz Bulldog remained on the farm. When someone at the Valley Cooperative asked him once about the pump truck in the Steinbach Gorge, he said, I knew the track was there because my uncle showed it to me. He knew it because the canal workers showed him. It is the same knowledge. It just arrived at the right moment. The lance fired on the third turn of the crank until 1978. Pum pum pum. Some places keep old information in their walls and their floors and their paths. waiting for the day when the new infrastructure is not enough. The Steinbach Gorge had been holding the 1889 mule track in its right wall for 68 years, while the world above it built new roads and new machines and new surveys. It had been waiting for a man who had learned the track from a man who had learned it from the men who built it, and who had kept using it long after anyone else thought it was worth knowing. The dam engineers had the gorge, Anton Bruckner had the wall. The difference between these two things was the difference between a pump truck on a road and a pump truck on the gorge floor. Old iron found the track that modern surveys had not found. The limestone remembered. Pum pum pum.